Hello everyone. So now we are going to see an implementation of the naive-based classifier focused mainly in categorical data. We are going to use this database that is available in this website, and these are the variables involved. You can just copy them and from the website and write them in your code as I've done here. So all these are the columns. In particular, this one is the class name, okay? So I saved the file in this local path, so you can replace that variable with your whatever local path is. So now we need to read that file. As usual, we are going to use pandas for that. No header here. And we need to add this option because in particular in this database they added quotation to the variable names, and we don't want to include the quotation in the string, so by adding that option we get rid of the quotations. And let's say that the columns of this data frame are going to be all our variables. You have to make sure that they are in the right order, right? So in the website you can see the meaning of each of the variables. These are the values each variable can take. All of them are strings, and make sure that when you print out the data, the variables are correct. Actually, let's do the following. We're gonna fill the NaN values with empty strings. Okay, here we go. So this is the class, is a binary classification problem, and all these are the variables. All of them are categorical. Here we are going to define our naive-based classifier. So we are going to receive one data point, the one that we want to classify, our training data, and let's say the class name, because we want to know which of the columns correspond to the class, right? So here we're going to extract all the possible classes. Here we're going to save a list with all the variables, I mean discarding the class name. Now we are going to use a dictionary to save the probability of each of the class values, right? In other words, like the probability of the class given the data. We're going to use a dictionary, but instead of using directly the probabilities, recall that we are just calculating the result of the multiplication in the numerator of the fraction, right? Of the posterior probability of the class. So it's not directly a probability, right? Because we are missing the denominator that normalizes the value. But also, another thing we are going to do in the implementation is that instead of using the product of the factors in the numerator, we are going to use the logarithm of it. Because we may have numerical issues if we go astray and multiply very small probability numbers. So let's call it log probabilities. And they are going to be saved in this dictionary. Okay? So we are going to calculate the posterior probability of each of the class values. We are going to accumulate the probability of the numerator. The log of the product is the sum of the logs, right? So this is why we start in 0 and then we are adding all the intermediate values of the factors. So recall that each posterior probability is the product of several conditional factors, which are the probability of each of the variables given the class, finally times the probability of the class. Each of the factors are going to need the number, or we're going to need to count the number of cases in where x take the value of the given variable and the class takes the value of the current class. For example, I'm going to comment this here. Recall that was each factor x given the class C was calculated as the probability of x and C divided by the probability of C. And this means we are going to count the number of cases in where x takes the given value of the variable and C divided by the number of cases the class is C. Okay, so the first thing we're going to need is the probability of the class. So we are going to count the number of times we get this class value. And is where the train data, the class name equals C, right? And we need to just count them, the number of rows, and this returns two values. We want the second one, which is the actual count, right? Okay, so we're gonna compute here the prior probability of the class, which is this count divided by the number of cases in our training set. Again, the number of rows. Okay, these values are needed for the calculus of the numerator product. In our case, it's going to be the sum. And now we need to go over all the variables. Right? So here we're going to count the cases in where the variable v matches the value of that variable for our data point, as we did in the examples in the slides before. And also the class is equal to C. So we are just counting here, and here we need two conditions. The first one is that our training data matches the class name. So we count all those cases, and also in the current variable that we are analyzing, there is a match with our data point. And again, we want to count these cases. So here we are going to accumulate the probability. Which is this logarithm. And instead of divided, recall that we must subtract the logarithm of the cases in where the class takes that value. Right, so recall that here we're just computing the logarithm of the probability of x, let's say the variable v of x, given the class. And this factor, recall that to calculate this probability, we need to count the cases in where the data point in that variable is equal to v and the class is equal to c, divided by the cases in where the class is equal to c. We compute that here, right? And we compute the numerator counts here. So this is why we divide them, but given that we are using the logarithm, we are subtracting them. Finally, the log of the probability of this class in particular, recall that is the product of all these factors, but given we are using the logarithm, is the sum. Sorry, here we need to accumulate, right? Because we're adding all these differences for all the variables. And here is going to be this accumulated product, but we need to add also the probability of the class, which is calculated here, but we are using the logarithm. So we are almost done, because now we have the log prob of every possible class, and we just need to choose the highest probability in order to classify. So we are going to say that the max class, let's do this list, is K for K and V. We're going to sort the log prob dictionary. Here we're just saying that we are sorting according to the second item, which is our probabilities in this dictionary, right? But we're just saving the key, which is the class. Recall that this dictionary is class and the values are the log prob. Also, we want to sort this in decreasing order. So we need to say that reverse is true. And this is going to return the full list, but we just want the first element because we want the maximum. So we can actually return this. Okay, let's try this. We want to select one data point. Could be any data.log 0. This is going to be the training data, and the class name we already defined here, right? Okay, here we go. So in this case, this is the classification for this data point. Okay, let's create now one training and testing set.